All right, good morning. This is a presentation on the engineering design process. All right, so our agenda is we're going to be talking about problems, then we want to explain the engineering design process, and then we're not necessarily going to talk about the next project build or the project because those are specific things that we'll do in class. So we're not going to focus on those specific things for this presentation. The engineering design process, and please make sure that you write this down because the engineering design process is a logical way or a logical process in which to identify problems, then design, create, and test solutions. So it is a logical process in which to design, create, and test solutions. Okay. It's actually made up of 8 different steps, and we'll go over these in more detail. So the first step is identifying the problem, then researching the problem, creating solutions, selecting and refining the solutions, modeling the solutions, testing the solutions, communicating the results, and last, improving the solutions. All right. So step number 1, and again, this is coming from chapter 11 in our textbook. I'm sorry, chapter 11 in our textbook. So, which is identifying the problem. And when we start really thinking about problems, a problem is a matter or situation regarded as unwelcome, harmful, and needing to be dealt with and overcome. Okay, so a problem is identified by our text is a matter or situation regarded as unwelcome or harmful and needing to be dealt with and overcome. Another part of your step 1, as we're identifying the problem, is there are different types of problems. There's social problems, there's personal problems, and then there's also technological problems. Please make sure to make a note of these, that social problems are problems within society, such as world hunger or crime. Personal problems are personal problems such as I'm hungry or I need to shave. And there's also technological problems. Technological problems where we understand that technology is things that humans have built. So technological problems are problems with things that humans have made. We also need to remember that all problems are an opportunity. So just because something is a problem doesn't mean that it's just a crisis. It is also an opportunity for us to learn from that problem and then get better from it. So once we have identified a problem, step number 2 goes into, well, now let's start researching the problem and start understanding why this problem is a problem. So in step number 2, we're learning about the problem. We're learning about what are some of the statistics about the problem, demographics, who does this problem affect? How does it affect other people? Is it really a problem? How long has it been a problem? And why do we care? So step number 2, that's when we're starting to do all of our background research. And again, step number 1, we identify the problem. Step number 2 is, okay, this is a problem, why? Okay? Step number 2 is after you've done your research, you want to write a problem statement. And a problem statement is a clear statement of what the problem is. Okay? So I like to express the problem statement as something is a problem because. So, for example, if we identified climate change as a problem in step number 1, and then we did some research on climate change in step number 2, then we could say climate change is a problem because. So step 1 is a problem because of step 2. Okay, remember we always use ELA standards as we're writing our problem statements, so we make a claim, then we cite it, where we got our information from, and then we clarify our statement as far as what we're doing with our work. All right, and step number 3, of the engineering design process is creating solutions. So creating solutions, we also call this ideation. This is in chapter 13 of our text. We're starting to identify potential solutions to the original problem that we've identified. And we also like to call this brainstorming. So again, brainstorming, we're thinking about different ways that we can solve the problem. There's a lot of different ways that we can start brainstorming. Some of those are sketching, so you can start like drawing out your idea. Designing is just planning and doing some additional research, and then questioning. Questioning is always important when you're developing solutions. So, for example, when you start questioning, you're asking questions. Well, how will this solve the particular problem that we've identified? Will it solve it, or will it not solve it? Is it putting a Band-Aid over it, or is it actually a true cure for the solution? And then graphic organizers are different things. All four of these are different tools to use as we are developing. So, as we have developed we brainstormed some potential solutions in step number 4 of the design process, or the engineering design process, now we are selecting and refining the solution that we're going to choose. And again, this is from chapter 14 of our text. So, and for the first thing that we do in step number 4 is we start selecting the best solution that we're going to go with. And then we start to refine that solution based off of the research and additional variables that we've covered. So, for example, we can say solution A is what we're going to go with. However, we might want to incorporate some additional tenets of solution B or solution C, or we would take out some things from solution A, or however, but we start to select and then hone in on the specific solution that we want. Okay? So some things that we want to consider when we're selecting and refining that solution is, how will this solution solve the problem? And then, is the solution realistic with today's technology? And can the solution be implemented now? If not now, when can the solution be implemented? Another thing to consider are there negative effects of the solution? And if there are negative effects, do they outweigh the benefits of the solution? So an example of this is cars. Cars allow us to get to different distances fast and safer. However, cars also produce some carbon gases which influence climate change. Are the negative effects of the pollution, do they outweigh the benefits? There's people on both sides of the issue. So that's why, there's a big push for electric cars, which significantly have almost no carbon output of them. So are there negative effects of the solution? And if there are some, do they outweigh the benefits? So another thing to consider when we're selecting refining solutions are the different advice given to us from different places. So external selection is those things that come from outside our group. So internal selection is within our group ideas within our group, and external selection is ideas from outside of our group. So just say if there was a team of 5 people working on a specific problem, internal would be ideas from those 5 people. External would be ideas from anyone outside that. Then some other things to consider. I'm going to go through these, but you need to consider the appearance of the solution, the function of the solution, the production of the solution, the safety of the solution. So the appearance is, how does the solution looks? Function is obviously, how does the solution work? Is it easy to use? Is it not easy to use? Does it require training? Production, how easy is it to make the solution? And safety, is the solution safe to use? So all of these things you need to consider as you are selecting and refining your solution. Other things are environmental impacts. We covered environmental impacts when we were talking about the car. Do the negative impacts of the solution, do they outweigh the benefits? And we also need to consider the resources available for our solution. So if we wanted to build a boat, but we had no wood, well, obviously that we'd have to consider some other type of resource. So resources we know are people, time, and money. Okay, and also capital. So after we have identified the problem, and then we started researching the problem, and we wrote a problem statement, and then we started doing some ideation, brainstorming about solutions, and then in step 4 we selected the best solution, we refined the solution. So all of that, all of those first 4 steps are part of the design stage, where we're designing and we're researching, we're planning our project, our creation. And step number 5, at this point, now we are starting to actually start to physically do something. Okay? So the modeling in step 5, this is primarily used to communicate and experiment with our particular solution, because things can work well and work great in our mind's eye and in our thoughts and on our paper, but we actually have to build something to actually determine, to see how it looks and how it works. So that's why we need to begin to model our solutions. So some of the things that step 5, modeling solution, is good for, is to communicate, experiment our solution. So it also includes, there's a couple different types of models. So the 4 different types of models that we kind of look at are graphic models, which are charts and graphs that show comparisons of numbers. And there's mathematical models, which are more linear, algebraic, trigonomic, calculate models. Then there's computer models, which are models that you can design something on the computer to kind of see how it works. And then there's physical models. So in this class, we kind of focus on more physical and computer models. But for the project that we're working on, we do more of physical models. And again, a physical model is pretty much something that we can actually physically touch. Okay. So there are 2 main types of physical models. The first of those physical models is what we call mock-up. Okay, and a mock-up, it's pretty much like a non-working model, and it's focused on the appearance of the solution. So then you also have prototypes, and prototypes focus are, first and foremost, a prototype is a fully functional model. Okay, so if we were talking about a car, if we were developing a solution for a car, a mock-up could be like a wood block of the car or a clay model of the car. A prototype is actually a fully functional vehicle that we could drive, that we could test on normal road conditions. And prototypes are focused on the function and performance of the model. So mock-ups generally focus on the appearance of the solution, and prototypes are focused, or well, they're fully functional, and they focus on the function and performance. In step 6, now once we have created our model, now we can actually begin to test it, the solution. And generally, step 6 includes 2 parts. It includes testing and assessing. Okay? So the first part in testing our solution, it is experiment and examination of the solution. So if we were building a car, okay, in step 5 we built the car. In step 6, now we're driving the car. We're experimenting with it under different circumstances and different weather environments, on wet roads, on dry roads, up mountains and hills. So that's what experimenting and examining the solution. And then the second part of step number 6 is the assessment, and that is a determination slash judgment made on the solution. So does the solution work? Does it not work? Does it perform well in certain situations? Or does it not perform well in other situations? So that is step number to test and assess a solution. So some parts of testing the solution are, remember, whenever we test it, it has to be based on the original design criteria. Okay? So if we're building a car, if we're trying to build a car that works great in snow, then we need to make sure that we test it in snow to actually make sure that it does what we want it to do. Okay? It also, testing focuses on the function, performance, and durability. So function is, does it work? Performance is how well it works, and durability is obviously how long does it work well. Okay? Testing also includes the human engineering, how it can be engineered. It includes the economics, how much does it cost to continually make whatever the solution is. And then the second part is assessing our solution. So remember, assessing your solution is a determination or judgment of the solution. Does it work? And again, assessing it needs to go back to what? The original design criteria. So if we're making that car for the snow, we tested it in the snow. Now, as we assess it, we need to assess it for the snow. Did it work? Did it not work? Okay? And the assessing is, again, the final conclusion of the designer. And it also can include trade-offs and substitutions. So here's the difference. Trade-offs and substitutions, vocab words, remember these. So trade-offs are generally focused on performance, whereas substitutions are focused more on need. Okay, so I'll explain it a little bit more. So a trade-off is, so our vehicle, it performs well. However, because a certain part of it is way too expensive, we have to use a different part, which is going to affect the performance. However, so that would be a trade-off. We're doing one thing for another. Okay, that's a trade-off. Now, the difference between a trade-off and a substitution is I can substitute let's say we wanted to build our car out of gold. Okay, now only a few people can purchase a car made out of gold. So rather than building the car out of gold, we're going to substitute the gold for a lighter aluminum alloy where more people can afford the car. That is a substitution. Okay? Trade-offs typically depend on you're doing one thing for another based off of performance or based off of some criteria, whereas the substituting is I'm substituting one thing for another. Communicating your solutions. So in communicating your solutions, there are different types of documents in which we communicate. Okay, obviously we can communicate verbally, but there are certain documents that we use as well. So one of those documents is called a bill of materials, and this is coming from chapter 17 of our text. So a bill of materials is all of the materials used in your particular solution. Okay, drawings, and we'll cover drawings a little bit more. So drawings are architect work, and what does your solution look like? Specification sheets, we call these spec sheets for short, because most people do not want to say specification sheets. So spec sheets, specification sheets, pretty much all the same thing. Okay, and specification sheets show the what each component of your solution can do. Okay, the specifications of it. For example, if we were building a bridge, how much can the different parts support? What do they need to be able to do? Okay, so these are the three types of communication documents: bill of materials, drawings, and spec sheets. Now, as I was saying, there's different types of drawings, and there's four main types. There's engineering drawings, architectural drawings, orthographic drawings, and then pictorial drawings. So an engineering drawing is the drawing of more of like blueprints, okay? And then architectural drawings. Then you have orthographic drawings. Orthographics is what we do in class. Obviously, we draw things in orthographic 3-view, front, top, and side. And then you have pictorial drawing. So a pictorial drawing is you actually drawing the solution, but you might be drawing the solution as it is actually working. So you might draw trees in the background. So for example, if we were communicating the solution of a car, we would show the car drawing, we would be drawing the car, maybe trees in the background, passing other vehicles or something along those lines. So these are the four types of drawings. But again, the main one that we use is orthographic 3-view or the orthographic. Okay, and then the last step is step number 8 in improving your solutions. So once you have developed your solution, you've tested your solution, you start creating you've communicated your results. Now improving your solution, and this is in chapter 18. I like to call this continuous improvement, because one of the things in our solutions, as we design them, we should always be thinking of different ways to continuously improve the solution and make it better. So some things in improving the solution can be additional trade-offs and substitutions, and we kind of explained that before in step number 6 as we are testing our solution. So again, step number 8 is continuous improvement, and it also can include some trade-offs and substitutions. All right, so in step number 8, obviously we're determining if the solution worked, how well did it work, and again we're starting to think again, and I'm going to bring all this together on our last slide. What other opportunities are there for our solution? Summing up the engineering design process, and I wanted to make sure that I put the engineering design process side by side with the design process, just so we can really get a good grasp of this. Remember, on the engineering design process, okay, you have identifying the problem, researching the problem, creating solutions, and refining the solutions. And if you look on the design process, all of that is in the design stage. So I'm thinking, I'm planning, I'm doing all of my research, okay, and those first 4 steps. Now in step 5, again, that is when I'm actually physically starting to create those solutions. So at that point, I'm producing the solutions. In step number 6, I'm testing it and assessing the solution. So in the design process, that's part of the use, and communicating the results. Obviously, that is also part of the assess. Now, step number 8. If you notice, that is back in the design stage. That goes back to the first, because remember, just like the design process is a cycle, the engineering design process is meant to be a cycle. So in step number 8, as we are improving our solution, we're identifying potential problems with our original solution that we've created, that we've marketed, that we've tested, that's out, okay? And now we're looking at ways to improve it. So we go back into identifying potential problems. And then we're researching, why is that, particular problem is a problem. Then we're creating those solutions. We're selecting and refining our solution. So we're making it better. So remember, the engineering design process, it is a cycle, okay, of just continuously improving solutions. So, in summation, the engineering design process is a process in which we identify potential problems, or we identify problems, And then we begin designing, creating, testing, and assessing solutions. Okay? So with that, I hope that this was beneficial for you, and please make sure to review this video as many times as you need. Hopefully it continues to help you. All right, take care.